Today we are going to start a new topic called integrals, and this would be helpful for all the students who are in grade 12. Okay, so as you know that integral is a reverse process of differentiation, right? So that's fine before. So have a look here. Differentiation of sin x we know is cos x, right? Differentiation of sin x is cos x. So we can say that integral of cos x would be sin x. That is, and in integration we put a constant called c. It is called integral constant. Similarly, you know that differentiation of x cube over 3, how to differentiate that? Let me differentiate that first. 1 over 3 is constant and x cube differentiation is 3x square. So 3 gets cancelled. So basically x cube over 3 differentiation is x square. So we can say that x square integration will be x cube over 3, right? And plus c is always there as an integral constant. So this is the basics of integration, right? We have certain formulas to learn for integration. Let's see. Some formula, as you can see, integral of x to the power n is x to the power n plus 1 over n plus 1. It means that if you have a variable x and it has some power n, so you just increase the power and divide by that same number. For example, integration of x to the power 5 would be x to the power 5 plus 1 over 5 plus 1 and plus the integral constant, which means x to the power 6 over 6 plus c, right? Okay, let's say if it is x to the power minus 3 we have to integrate. So it would be x to the power minus 3 plus 1 all over minus 3 plus 1 and plus the integral constant. So it would be x to the power minus 2 over minus 2. Okay, and which can be simplified further as, I'm sure you must be knowing it, x to the power minus 2 you bring it down and you will get minus 1 over 2x square and plus c, which is the integral constant. So this is how we integrate the x to the power n. Let's have one more example we'll discuss. If we have integration of 1 over x to the power 3 over 2, how to integrate that? So first of all, we'll bring this entire thing in the upper part, so the power would be negative, and then we will integrate, right? So x to the power negative 3 over 2 all over negative 3 over 2 plus 1, which is x to the power minus half over minus half, and we write it as, you know, x to the power minus half means you will bring it down, and this minus half will come front and it will become 2, right? Because it is in the denominator, right? It will be minus 2. And x to the power minus half, I bring it down, making x to the power half. When we bring it up to down or down to up, we change the sign of the powers, right? So negative 2 over root x, that is the integration, and plus c is the integral constant, right? Now here we have integration of dx. Integration of dx means integration of 1, right? One integration would be x. Why? Because x differentiation was 1. So integration of 1 would be x, right? This is the formula. Similarly, if I ask you what is the integration of 5 dx? So because 5 is a constant, so its integration would be just 5x. If I ask what is the integration of pi is a constant, it would be pi x. Similarly, if I ask what is the integration of e dy, please understand guys, e is a constant, right? The way pi is a constant, e is also a constant which is equal to 2.71, approximately equal to, not equal to. So e is a constant, so it is just e, and it is integration of dy. Mind it, it is not integration of dx, it is integration of dy. So integration of dy would just be y, and plus c is the integral constant, right? So like that we have different formulas of integration. Cos x integration is sin x, sin x is minus cos x, sec square x integration is tan x, cosec square x is minus cot x, and like that, right? Let's move on. So you have all the formulas with you. We'll do the questions. Let's have a look at some properties of definite indefinite integrals, right? So the property says that the process of differentiation and integration are inverses of each other. If a function is differentiated, this is the differentiated value, right? So when we integrate this, we'll get back again to the function, right? Any function fx, if we differentiate, we get f dash x. If we integrate, we'll get fx. That's what it says. That is the first property. Second property is that if there are two indefinite integrals with same derivative, lead to the same family of curves, and so they are equivalent. It means that if you have integration of x square dx, right, or you have integration of y square dy, or you have integration of z square dz, all of them are same. Why same? Because all the functions are same, right? So variable doesn't matter in each individual case. So x square dx integration or y square dy integration or z square dz integration, all three are same, right? Fine. So that is the second property. Third property is if you have the sum of two functions which are to be integrated, you can break it as integration of first function plus integration of second function. So sum you can break it into two parts, right? Move on. Fourth property is if there is a constant k which is with the function, you can simply keep it out, just need to integrate the function. So that is a fourth property. For example, if you have to integrate sin x, so because 5 is a constant, so you will keep out and you need just to integrate the sin x part, and is from the formula is minus cos x, right? And plus c will the integral constant, so minus 5 cos x plus c, right? Okay. Now this fifth property is just the extension. If you have to integrate k1 f1x, k2 f2x, and like that you have kn fnx, where k3 and like that up to kn are constants. So you will simply take 2 and like that kn in each integration, and you just need to integrate f1x, f2x, fnx like that, right? So basically it is the extension of third and fourth property. For example, let me take an example for you. If you have integration of 5 sin x minus 3 cos x plus 2 e to the power x, if you have to integrate this, writing dx is very important, right? So 5 will be constant. You just need to integrate sin x, which is minus cos x, and minus 3 is out, and cos x integration is sin x plus 2 e to the power x integration is e to the power x, and plus c is my integral constant. So this is what property number 5 is explaining you, right? Question number 6. Integration of 4 e to the power 3x plus 1 dx. Now because 4 is constant, so we write 4, and e to the power 3x integration would be e to the power 3x and divided by 3. Why? Because x coefficient is 3, right? Plus 1. 1 integration we know is x. It's 1x, right? Which is x. And plus c is the integral constant. You know, in complete integration question, we will give the integral constant at the end. After integrating all of them, we'll just put c at the end, right? Okay, let's try question number 10th. Square root of x minus 1 over root x whole square. Guys, please understand, here we cannot use this formula. That you need to understand. We cannot use x to the power n integration as x to the power n plus 1 over n plus 1. Like, we cannot say that this power 2 would become power 3 and over 3. No, right? First of all, we'll have to break this up. Like, root x minus 1 over root x whole square. So I'm solving it here, number 10. X minus 1 over root x whole square. We are integrating. So let me expand it, dx. So root x square is root x square minus 2 root x times 1 over root x. Correct. So I am integrating it, I am simplifying it further. Root x square is just x plus 1 over x minus 2, right? Integration of that. Now integration of x is x square over 2. Power would increase by 1 and we divide by the same number, plus 1 over x integration is ln x, right? 1 over x integration is ln x. See, 1 over x you cannot integrate on this formula. Why? I will explain. 1 over x, and like you can write, but then you cannot integrate like x to the power minus 1 plus 1 all over minus 1 plus 1, right? Why? Because your denominator will become 0. So you cannot integrate this way, right? Okay. So 1 over x integration is ln x plus minus 2 integration would be minus 2x and plus c, right? So that is my answer for number 10. Let's try question number 13. I'm doing number 13 for you. In number 13 we have x cube minus x square plus x minus 1 and all over x minus 1. So first of all guys, you will have to divide this by polynomial division, right? So I'm dividing that by polynomial division. So x cube minus x square plus x minus 1. So by what number should I multiply first? I believe you know how to divide polynomial division. X minus 1 multiplying with x square will give x cube. Getting x cube is important first. That is why we multiplied by x square. And then minus x square times minus 1 is minus x square. Okay. In division we finish. And this also finish, right? Now we bring x minus 1 down. Now x minus 1 should be multiplied with plus 1. So we are left with no remainder. So this entire thing can be written as just x square plus 1. And integration of x square is cube over 3 plus integration of 1 is just x, right? Okay. Let's do question number 19. Sec square x over cosec square x dx. Guys, whenever you are confused, always come into sine and cos form. So I'm writing sec square x, I'm converting to 1 over cos square x, and over cosec square x I'm writing as 1 over sine square x, right, dx. And so this goes up, right? So eventually dx, which is basically tan square x, right? Square x, the integration formula comes to my mind. Integration formula says integration of sec square x dx is tan x, right? So basically I into sec form. From trigonometry we know that tan square x is actually sec square x minus 1, right, dx. So sec square x, let me write that, minus 1 integration is x. Good, fine. Let's try question number 22. Question is, differentiation of a function fx is given, right? Fx has been differentiated and the differentiation is 4x cube minus 3x to the power 4. And they also say f2 is equal to 0. Okay. So first of all, if we integrate this, we should fx, right? Because fx differentiation is this. So if we integrate fx, I'm integrating that 4x cube minus 3 over x to the power 4 dx. So 4 is a constant and x cube differentiation is x to the power, x cube integration is x to the power 4 over 4 minus 3 is 3. Now over x to the power 4, first of all I will have to bring it up. So it would become x to the power minus 4. Now I'm integrating this over the same number, right? And c. Let's simplify. So 4 cancelled, x to the power 4 minus 3 x to the power minus 3 over minus 3 plus c. And minus 3 and minus 3 will be cancelled. It would just be plus that, right? So 1 over x cube plus c. Okay. And they have said f2 is 0, means when x value is 2, function value is 0. 2, function value will find the value of c. Okay, so which is 16 plus 1 over 8. So c is equal to negative 16 minus 1 over 8. So which is nothing but negative 128 minus 1 over 8, which is negative 129 over 8. So my c value, so let me write fx nicely. So fx would be x to the power 4 plus 1 over x cube and minus 129 over 8. So which is option A is the correct answer, right? Methods of integration. First method we'll learn is integration by substitution. So let's learn that. Okay, first of all, let's do question number 2. We have to integrate log of x whole square over x, and let me write it as dx. Okay, so substitution method says that you suppose that value from the integral part whose differentiation is already given in the question, right? Again repeating, you will suppose that value as u or something whose differentiation is already given in the question. So here in this case, I will suppose log x as u. Why? Because log x differentiation is 1 over x, which is already given in the question, right? So this is what we have supposed. SUPPOSE. The moment you suppose something, you need to differentiate both sides with respect to x, because the question is with respect to x. So log x differentiation is 1 over x equal to, I'm differentiating with respect to x, right? Okay, then I will bring this dx this side. So I get over x equal to du, right? Please understand, guys, my aim to do all this is entire question in x I have to convert into u. So how would I write that? See this, dx over x portion is du. So for this I will write du. And this log x I have supposed as, so for that I will write u square. So actually my question has become u square du, right? And we know that integration of u square is u cube over 3, right? Okay, done with integration, we'll just replace the u value what we had supposed. So log x whole cube over 3, right, plus c. Let's do next question. Question number 4. Question number 4 says, let's do question number 4. Integration times sine of cos x dx, right? I would suppose cos x as u. You know, there is a reason. Why? If I suppose cos x, my differentiation is sin x, which is already given in the question. So I'm writing, right? Differentiate with respect to x. So cos x differentiation is minus sin x. Okay. I will bring all the x's together. So it is minus sin x dx equal to du. And yeah, so I will write sin x dx negative du. Okay, please understand guys, the question was this, right? For sin x dx, I will write minus du. That I did for sin x dx. But I will write sin cos x I have supposed as u, so it is sin u, right? And sin u integration is negative cos u. So two negatives makes cos u plus c. Plus c is the integral constant, and u was my cos x. So I will write cos of cos x plus c. That is my answer, right? Okay, let's do number 10. Get a space. I'm solving it here, number 10. It is 1 over x minus root x. So I will rewrite it nicely as 1 over. I will take root x common from both the terms in denominator. Okay. So I will suppose this as u. My supposition is root x minus 1 equal to u. Okay. Let's say this. Say respect to x. So root x, we have learned differentiation is 1 over 2 root x. This you can memorize. Root x differentiation is 1 over 2 root x, very frequently used. And u differentiation is, right, this side, x over 2 root x equal to du, right? Here I need dx over root x. I don't need 2, right? So I will bring this side. So actually my question has become integration of 2 du, and for the lower part of root x minus 1 I will just say, and you know that plus c, right? And 2 ln u was root of x minus 1. I'm writing root of x minus 1 plus c. Good. Question. Let's do question number 12, right? It is integration of x cube minus 1 whole to the power 1 over 3 x to the power 5 dx. You know guys, whenever you suppose, always try to suppose the complex part. So here complex part is x cube, suppose x cube minus 1 whole to the power 1 over 3 would be u. So basically, let me simplify it nicely and then we'll differentiate u cube, right? And now we'll differentiate with respect to x. X cube differentiation is 3x square dx. I'm just writing it now. And u cube differentiation is 3u square du. Basically it was du over dx, so I brought dx this side. Good. All my x's are on one side and all my u's are separate. So we got x square. Okay. 5. I am not disturbing right now. Don't worry. Okay. This I will split as x cube and x square dx. I hope it is now getting, guys. X cube has converted to u. Now I will integrate it. First we write nicely. This u and u square will become u cube. Now first we'll break the bracket. It will, and u to the power 6 integration is 7 plus u to the power and plus c. And guys, u was my this thing, right? So I will write it as x cube minus 1 whole to the power 7 over 3 divided by x cube minus 1 whole to the power 4 over 3, because power is 4, of substitution method in integration. Remaining part we'll learn in the next session. Thank you.